Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do, which is hang out here on Wednesdays and work through some math problems and just really dive into figuring out like some of these math problems. Like I said, my voice is shot. I did some recording with Dr. A last week. I've done a little bit this week, and I think I'm like getting sick or like, I don't know, I have a cold or something. And so this poor voice, I feel like, has seen better days this year. I feel like I've lost my voice more this year than I've ever lost my voice. So we are going to try to get through as much of this as we can, but we may not be here for an hour if this continues. I am from the Central Florida area. I am an assistant principal, just a little bit about me, and I am obsessed with my dog, Pudge. He is a Great Dane, and he is just so awesome. So in the comment box, let me know where you're from, what test are you prepping for, and are you an animal person? And if so, what is an animal that you have always wanted, but you've never had? I can tell you right now, it ain't a hamster or a guinea pig for me or a rabbit. I have never been a kid that wanted a furry rodent. It's just not my style. Some kids grow up and they just really, really want one of those. And I'm just not that kid. But I've always wanted like those big, massive, like fluffy, St. Bernard dogs that just think that they're big lap dogs. Like I love Pudge and he's so big, but I wish we could have one of those. We just don't have the space for it. But I think that that would be so awesome. All right, so where are you from? What test are you prepping for? And what kind of animal do you wish you could have that you've never had? A snake, a horse, a tiger cub? So cute. Totally random. when I was younger, I was probably like 11 or 12, and we used to help out. We were like huge volunteers for the Canine Companions for Independence organization. And so we would go to their galas every year, and I would volunteer. And Jack Hanna was there as like the guest speaker. And he brought a bobcat baby. Like this thing was like 8 weeks old, and I got to play with it. And it was so cool. Now, obviously, like it had a mom, and they like ended up like they like trained it to release in the wild and all of that. Like it was fine. It was a rescue mission, but it was so cute. You're from Florida but live in Texas. You sound like my husband. He's from Texas but lives in Florida. So that's kind of funny. What part of Texas are you from? All right. Every week I always have a next week section. And so if there is something that I'm not going over with you, or you wish I would have gone over with you, or you're like, I wish you would go over this concept, let me know in the comment box. I'm happy to go over it. So just let me know. Ooh, sorry about that. Just let me know in the comment box what you want to see me go over in the upcoming weeks. And I'm happy to do that. And yeah, I think that's it. So where are you from? What test are you prepping for? What kind of animal do you want? And let me know in the comment box what you want to see me go over. And let's go ahead and get started with the first problem. I will say today's lesson is really focused around the language of mathematics. A lot of what we are doing today is around the language of mathematics and translating the English language into mathematics, which is something that I see that a lot of people struggle with. So we're going to go over some problems that directly relate to that tonight. So yeah, let's go ahead and get started. The lengths of the sides of a triangle are consecutive even numbers. What is the length of the longest side if the perimeter is 48? What is the length of the longest side if the perimeter is 48? So again, like I said, we're talking about language. So we've got lengths of the sides of a triangle. So the first thing I'm going to do is draw a triangle. First thing I'm going to do is draw a triangle. There's my triangle. And they are consecutive even numbers. So the lengths of all of the sides of these triangles are consecutive even numbers. What does the word consecutive mean? What does the word consecutive mean? Back to back, right? So like 4, 5, 6, 7, 8, 9, 1, 2, 3. Those are consecutive. But this problem specifically said consecutive even numbers. Consecutive even numbers, which means that I have 12, 14, 16, or 22, 24, 26, or 100, 102, 104. So they are back to back. They are consecutive, but they are consecutive even numbers, if that makes sense. And so I'm looking for numbers that are back to back that are even. And I'm trying to reconnect my iPad. So give me a second. It's just acting up a little bit. No big deal. Okay, it says that it's connected. But I'm not seeing it. All right, we're going to quit this and we're going to just start over. No big deal. All right. Sorry, guys. So I want you to think about how would you solve this problem if you knew we had consecutive even numbers that we had to do. A lot of people mistake consecutive even or consecutive odd with consecutive. And that is a total miss because it's going to give you the wrong answer. So let's chat. Come on, computer. There we go. All right. So consecutive even numbers. So this means that if this side is x, then this side is going to be x plus 2, and this side is going to be x plus 4. How do I know that? Because if I just choose some random consecutive even numbers, let's say 8, 10, and 12, if the first number is x, how many do I have to add to get to the second number? X plus 2. And how many do I have to add to get to the next number? X plus 4. Exactly. So it says, what is the length of the longest side if the perimeter is 48? I know my perimeter is 48. Perimeter is the distance, the length distance around the outside. So I'm doing x plus 2 plus x plus 4 equals 48. And you're like, how did you get that? Well, I added this plus this plus this equals 48. That's what perimeter is. So I've got x plus x is 3x, 3 x's, right? And I've got 4 plus 2 is 6 equals 48. At this point, this should look real simple to you. This should look like basic pre-algebra. So for my elementary people who may not need to know how to solve this problem, you definitely should have an understanding of how to get from here to an answer. So I'm going to subtract 6 from both sides. So I get 3x equals 42. Divide both sides by 3 to get x by itself. X equals, I'm going to use my handy dandy calculator. 42 divided by 3 is 14. Now, don't get tempted to circle 14 because that's not what they asked us for. They asked us for the length of the longest side. What did I just find? I just found the length of the smallest side. So what do I have to do to find the longest side? I have to do x plus 4. So 14 plus 4 is 18, which is D. Language is everything. Now, I will say a common error that people make is that for consecutive, they'll do x plus 1, x plus 2. But they will also, if it says consecutive odd numbers, people will do x plus 1, x plus 3. But I want you to think about what that does for us. Let's say I have odd numbers, and this is like a total side note. So this has nothing to do with the problem we're solving. But let's say I have consecutive odd numbers, 5, 7, 9. And let's say x equals 5. What am I adding to get to 7? I'm still doing x plus 2. And what am I adding to get to 9? 5 plus 4 is 9. I'm still doing x plus 4. If I did x plus 1, x plus 3, and I started with 5, I would have 5, x plus 1. 5 plus 1 is 6. 5 plus 3 is 8. So my pattern would be 5, 6, 8. Are those consecutive odd or even numbers? They are not. And that's one of the most common errors people make if they're doing consecutive odd numbers is they will overuse the idea of odd numbers in their problem, and then they'll get the wrong answer. So just think about that. All right, let's go ahead and move on to problem 2. In the figure shown, point O is the center of the circle. One vertex of the square lies on the circle, and the opposite vertex is point O. If the area of the shaded region is 36 pi minus 18, what is the perimeter of the square? What is the perimeter of the square? So this is an interesting problem, and it took me a hot minute to solve it. There are a couple of different ways that you can approach this. You can approach this from a very algebraic standpoint and solve it. But you can also approach it from a conceptual standpoint by thinking, okay, if I have this circle, right? And I've got the area is here. I know that this right here is going to be the radius. And I have this square, right? I have this square that's being taken out. Typically, when I'm looking for area of a shaded region, I'm going to do area of the whole thing minus area of the part to get the shaded region, right? Well, area of the whole thing is going to be pi r squared, and area of the part is going to be s squared. Side squared, right? Because side times side is side squared of a square. Are you following me? Well, if the area of the shaded region is 36 pi minus 18, and I overgeneralize this, 36 pi minus 18, then 6 would be my radius. Do you agree? 6 would be my radius. Do you agree? Because 6 squared is 36. So 6 equals r. Following? And then I have s squared is 18. So s is going to equal the square root of 18. Following? Okay. So then if that's the case, then I can go ahead and say that if s is the square root of 18, then I can do the square root of 18 plus the square root of 18 plus the square root of 18 plus the square root of 18 to get my answer. Correct? Following? So then, because the side is the square root of 18, I have 4 square roots of 18. And the square root of 18 is the same thing as 2 and 9, 3 and 3. So I have 3 square roots of 2. So I have 3 square roots of 2 times 3 square roots of 2, which equals 12 square roots of 2, which is C. Now, there's another way that we could solve this, and it takes a lot longer, but conceptually, that's how we could solve it. Conceptually, that's how we could solve it, right? So if that's the case and we want to solve it a different way, I'm going to go ahead and actually duplicate this because some of you are going to be like, I solved it a very different way and I got stuck. And that's okay. So let me quickly show you. Now, I am not going to completely solve this out the second way because otherwise we could spend the entire time today solving it like this. But I am going to solve it conceptually for you this other way. So I know that area of my shaded region is still going to equal pi r squared minus side squared of my square, right? Equals area. I'm going to use the substitution method to replace area with this. So pi r squared minus s squared equals 36 pi minus 18. Are you following? Now, I know that in a square, if this is s and this is s, this is going to be s square root of 2. So radius is going to equal s square root of 2. So I can literally replace radius with s square root of 2 squared so that I have one variable. S squared of 2 times S squared of 2 equals S squared, and square root of 2 times the square root of 2 is the square root of 4, which is 2, right? So 2S squared. So 2 pi S squared minus S squared equals 36 pi minus 18. Factor out the S squared, and I get 2 pi minus 1 equals 36 pi minus 18. I'm going to shrink all this down. So then I can divide both sides by 2 pi minus 1. S squared equals 36 pi minus 18 divided by 2 pi minus 1. Now, I could do that in my calculator, but none of my answer choices have pi in them. So I want to try to factor something out. In the 36 pi minus 18, I can factor an 18 out. 36 divided by 18 is 2. 18 divided by 18 is 1. What just happened? That is cool. 2 pi minus 1 can cancel with 2 pi minus 1 because it's a whole factor. Now, I cannot cancel this pi and this pi because this is being added and subtracted to something, as is this. So that does not work because those pi's are not necessarily factors of the whole thing. But because this entire factor is a factor and I can cancel it out, S squared equals 18. So S equals the square root of 18. Hey, wait a minute. S equals the square root of 18. Now I can just do my perimeter, which is the square root of 18 plus the square root of 18 plus the square root of 18 plus the square root of 18. I know that was a long problem, but how cool was that problem? That was a super, super fun one. All right, let's go ahead and look at problem number 3. All right, we're going to go into some more language problems here. So this is really for everybody, even though, you know, some of these problems may be more algebraic or some of these problems may be more on the core GK kind of vein. The process of this is super important. So the sum of the least and the greatest of 3 consecutive integers is 60. The sum of the least and the greatest of 3 consecutive integers is 60. What is the value of the smallest integer? What is the value of the smallest integer? So let's chat about this. The sum, which is the answer to an addition problem, of the least, smallest, and the greatest, biggest, of 3 consecutive integers. So in this case, we have 4, 5, 6, 7, 8, 9, 15, 16, 17. They're back to back to back. So in this case, we're not doing plus 2 plus 4, but we're doing plus 1 plus 2. And here's why. If I have 5, 6, 7, and this is x, how many am I adding to get to 6? 1. How many am I adding to get to 7? 2, because these are consecutive. They're not consecutive even. They're not consecutive odd. They are purely consecutive. So I have integer 1 is x. Integer 2 is x plus 1. And integer 3 is x plus 2. And it says the sum of the smallest and the largest of these integers is 60. So I'm going to add the smallest and the largest and get 60. X plus 2 equals 60. It seems super straightforward when we do it together. However, people freak out when they see words and math together. X plus 2 equals 60. 2x plus 2 equals 60. Subtract 2 from both sides. 2x equals 58. Divide both sides by 2. X equals 29. Now, what did the problem ask us for? What is the value of the smallest integer? Well, I found x equals 29, which is the smallest integer. So in this case, what I solved for actually is the correct answer. All right, let's go ahead and move on to problem 4. The sum of 4 consecutive integers is y. Which of the following represents the sum of the first 2 integers in terms of y if the first integer is equal to x? What is the sum? Which of the following represents the sum of the first 2 integers in terms of y if the first integer is equal to x? So the sum, answer to an addition problem, of 4 consecutive integers is y. So this means that x plus 1 plus x plus 2 plus x plus 3 equals y. The sum equals y. Which of the following represents the sum of the first 2 integers? The first 2 integers are right here. So, in terms of y, if the first integer is equal to x, if the first integer is equal to x. So, these two added together is 2x plus 1 equals y. However, if we are looking at it as in terms of y would be an x equals equation. So that means that A is not the correct answer, because if we're doing it in terms of x, x is in the middle of the problem. If we're doing it in terms of y, y is in the middle of the problem. So I need to rewrite this and have it equal to x. So I'm going to subtract 1 from both sides. So I have 2x equals y minus 1. And then I'm going to divide everything by 2. So I get x equals 1/2 y minus 1/2. And this is my fault because I did it in terms of x, not in terms of y. So this should actually be 1/2 y minus 1/2. So the answer would be B. Questions? All right, let's go ahead and do problem 4B. The sum of 5 consecutive odd integers is 45. Which of the following represents the product of the third integer and the sum of the first 2 integers? This is a very interesting question as well. So the sum of 5 consecutive odd, 1, 2, 3, 4, 5, equals 45. So I'm going to add all these things together. So I have x plus 2, x plus 4, x plus 6, x plus 8. Because we remember, if our consecutive odd integers are 5, 7, 9, 11, I'm still adding 2, 4, and 6, right? So in this case, I'm going to add all my like terms together. X, 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 x. So 5x plus 8 plus 2 is 10. 6 plus 4 is 10. 20 equals 45. Subtract 20 from both sides. 5x equals 25. Easy peasy, divide by 5. X equals 5. That wasn't the hard part. Now we need to read our question to really figure out what the question is asking us. The question is asking, which of the following represents the product? So I know I'm going to be doing a multiplication problem of the third integer, which is going to be x plus 4, times and the sum of the first two integers, x plus 2. Now, obviously, let's plug those in. So if that's not the way your brain works, let's go ahead and erase that. And let's say, hey, look, we have 5, 7, 9, 11, and 13 because our first integer is 5. 1, 2, 3, 4, 5. 5 consecutive odd integers. So we have the product of the third integer, which is 9, times the sum of the first two integers, which is 12, because 7 plus 5 is 12, and all of that equals 108. Either way is a way that you can look at it. Questions about questions about that? All right, let's go ahead and move on to the next problem. Stephen drives 15 miles per hour slower than Jamie. With 3 more hours of driving time, Stephen travels a total of 350 miles, compared to Jamie, who travels 300 miles. At what speed is Jamie driving? At what speed is Jamie driving? All right. So when I see a problem like this, I'm immediately going to think distance equals rate times time. I'm immediately thinking distance equals rate times time. Now, how am I using that? I don't know yet, but I see a rate over here, 15 miles per hour. I see a distance over here, 350. I see another distance, 300. So we've got some distances, we've got some rates, we've got some times. So let's set up some equations and see what we can work with. Stephen drives 15 slower than Jamie. So Jamie minus 15. Stephen also has 3 more hours of driving time and a total distance of 350. So Stephen's distance equals his rate times his time is t plus 3. 3 more hours. And then we've got Jamie, who has a distance of 300, equals, she's just J, her speed is J, and her time is T. Because Stevens is completely based off of Jamie's stats. So her speed is J and her time is T, and then Stevens is adjusted based on that. Now, I've got multiple variables here. So what I want to do is I want to solve for a variable in this equation that I can then substitute back in so I only have one variable. So what I'm going to do is I am going to divide both sides by J so that T equals 300 divided by J. Now I can literally use substitution and solve for J. I'm going to plug this in for T because T equals that. So now stick with me, y'all. This is where things get a little hairy. So I have 350 times j minus 15 times 300 divided by j plus 3. I'm going to use the distributive property to solve this because I'm trying to figure out what this all even means. So 350 equals distributive property. FOIL this baby out. So j times 300 divided by j. J times 300 divided by j. These j's cross off. So I have 350 equals 300. J times 3 is 3j. 15 times 300. 4,530 divided by j. 15 times 3, 45. I want to get everything together on the same side. So I'm going to subtract 300 from both sides, but add 45. Subtract 300, add 45 to get my constant. 350 minus 300 plus 45 is 95 equals 3j minus 4,530 divided by j. I don't like having a j in my denominator. So I'm going to multiply the entire thing by j. I'm going to multiply this entire thing by a value of j. You're going to see why. So I have 95j equals 3j squared. Now this j crosses with this j, and I have minus 4,530. I like my j squared to be positive, so I'm going to subtract 95j from both sides. So I have 0 equals 3j squared minus 95j minus 4,530. Now at this point, I'm going to use quadratic formula to solve. Now at this point, I'm going to use quadratic formula to solve. Now, I am going to blow through this quadratic formula stuff because it's not really yes, we need to know how to do it, but the relationship of it to the problem is not really as important as the distance equals rate times time. So if you are taking anything that requires an understanding of quadratics, you need to know the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, where this is a, this is b, and this is c. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, I will say, if I subtract a large value like this, I'm going to end up with a negative speed. And remember, we're solving for j over here. We're solving for j, and j is Jamie's speed. So I'm not going to have to go back and finagle this or solve for something else. So because I'm solving for j, if I do 95 plus a value, I'm going to get a positive answer. But if I do 95 minus a really large value, I'm going to get a negative answer, and I don't want a negative speed. So after I solve all of that, I'm going to end up with 57.7 as my answer. Now, like I said, I'm not going through all of that because I don't want to spend too much time on this problem. If I started solving this problem and got to about here, at this point in my study pattern, I would know that this problem is going to take forever. And I would honestly stop and flag it and come back to it. It's not worth spending 7-8 minutes on if this is the way that you're going to solve the problem. It's just not. The store is having an end of year sale. Buy one, get one 40% off. Jamie decides to purchase 2 pairs of shoes, each originally costing $52.99. If tax is 6.5%, how much is Jamie's total bill going to cost? If tax is 6.5%, how much is Jamie's total bill going to cost? So, the store is having an end of the year sale. Buy one, get one, right? We're all familiar with this. And she purchases 2 pairs of shoes, and they each are $52.99. So I'm going to add shoe plus shoe, and then I'm going to multiply that times my tax. And I'm going to get an answer, right? Now, I can multiply shoe times 1 and my tax, or I can add shoe plus shoe times my tax rate and then add it back in. Doesn't really matter how you do it. Now, I am not going to multiply it times 6.5. Why? Because this is not the decimal form of that percent. That is not the decimal form of that percent. This right here, and this is for y'all. Woo! This is for everybody. Everybody needs to understand how to convert in between percents and decimals and ratios, right? So if this is my percent and I need to convert it to a decimal, I need to move my decimal place 2 places to the left. I need to move my decimal place 2 places to the left. 1, 2. Now, I have 1 open spot, so I'm going to put that 0 right there. So my decimal is 0.065. The temptation would be to do 0.65, but that would be 65%, and that is absolutely not the amount of tax we're paying on this. So my decimal is 0.65. Now, I want you to watch what's going to happen. So I have $52.99 plus 40% off $52.99. So $52.99 times 40% off, which as a decimal, let's move that decimal 2 places to the left, 0.40 equals, I'm going to use my 4 function calculator to help me out on this. $52.99 times 0.4, $21.19 with a 6 at the end. So that's going to actually round up to 20 cents. Now, with that said, is that what I'm paying or is that my discount? This value is the discount, not what I'm paying. So I need to then do $52.99 minus $21.20. And again, I'm going to use my 4 function calculator. Which is $31.79. So $52.99 plus $31.79, which equals $84.78. Now, that is my total bill without the tax being added. That is my total bill without the tax being added. So at this point, if I was crunched for time, I know the answer isn't A or B because that's less than my total bill. And what I know about taxes is that it doesn't add $30 to my bill, right? Unless my bill is really high. For an $84 bill, it's not going to turn into $112 with a 6.5% tax rate. So if I had to just do a wild guess because I was running out of time, at this point, I would choose C. Now, let's explore that. $84.78 times that 6.5% equals $5.51. And when I add that to my $84.78, we get $90.29. Now, let's go back to both of these scenarios. I could also, instead of multiplying by the discount, I could multiply $52.99 times the percent that I'm paying, and that eliminates one step out of this process. So this right here is a two-step process because I'm having to multiply by the discount and then subtract it out, when I could really multiply by the percent I'm paying, and then I don't have to do any subtraction. One less step means saving time. So if I'm getting 40% off, how much percent am I paying? Knowing that a whole is 100%. 60%. $52.99 times 0.60. $31.79. It matches. And so that's one way we can solve it. So like two different ways gets the same answer. Now going back to this one right here. If I did 84.78 times 1.065, like if I'm dealing with taxes or something like that, I can multiply it by my whole plus, which is this one, the 0.065, and watch what you're going to get. If I use my calculator, 84.78 times 1.065 equals 90.29. Still matches. That's pretty cool, huh? All right, we're going to cut it out here because this voice has officially been shot. Like, you can hear it. So we're going to cut it off there. Let me know in the comment box what you want to see me go over in the upcoming weeks, and I'm happy to go over it. We have that next week section right there. So let me know in the comment box what you want to see me go over in the next coming weeks. I look forward to seeing you next week. If you celebrate Easter, I hope that you have a fantastic Easter weekend this weekend. And I look forward to seeing you next week. I'm going to turn it back over to Dr. A, and I will see y'all next week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.